Let's take a look at another example together. So let's try to factor this quadratic trinomial, x squared plus 7x plus 10. Again, you can try a common factor for everything. It's not there. You can try grouping. It's not there. We need something else. So let's think about what we want to do in sort of a somewhat more systematic way from the guess and check. So we use the guess and check as our springboard into a method that might actually be viable. To factor this, here's what we need to do. We need to find two factors of this number c whose sum is b. And if you think back to the previous example we looked at, that's exactly what we were doing in our guessing and checking. We wanted two numbers whose product was 20, but yet when you added them together, we got that middle term 9. Same thing here in general. So to figure out an appropriate choice for the two numbers that we want to put in their factorization, we want their product to be 10 in this case, and their sum to be 7. Let's see if we can find such things. So here we go. So we want to find factors of that constant term 10. Well, let's try some factors. How about 1 and 10? Their product is 10, and what's their sum? If I add them together, I'd get 11. Well, that's not going to work out because I want 7 here. So what's another factorization? How about 2 and 5? Those are factors of 10. Why? Because their product is 10. And what about when you add 2 and 5? We get 7. Well, we've hit gold because that tells me that I can now factor this as x plus 2 times x plus 5. Let's check and make sure that what we found here in this chart is accurate. X times x, x squared. Outer terms, there's the 5x. Inner terms, that's the 2x. 5x and 2x give me the 7x because their sum is 7. 2 times 5 is 10. This works. So now we're starting to develop a systematic way of the guess and check philosophy. Let's try another one together. X squared minus 11x plus 18. What do I want here? I want to find two numbers whose product is 18 and yet whose sum is negative 11. How can we possibly do that? This is a little tricky because the factors of 18, we want the sum to be negative 11. Like if you think of factors like, for example, 3 times 6. You take 3 and 6 and add them together, you're never going to make it negative. How can I possibly think of factors of 18 whose sum will be negative? What's the key idea? The key idea is to realize that really these two numbers each have to be negative. A negative times a negative is a positive. So that tells me, when I see that this is a positive number and this is a negative number, that tells me that both numbers have to be negative. Neat. So, factors, how about negative 1 times negative 18? The product is 18, and what's their sum? If I take negative 1 and add it to negative 18, I get negative 19. Notice that my sum is negative, that's good, but it's not 11. Not so good. Let's think of a different factorization in our guess and check. Negative 3 times negative 6. Product is positive 18. What happens when I add those two numbers together? You take negative 3 plus negative 6, we get negative 9. Not so good. Not so good. Let's try another one. How about negative 2 times negative 9? The product there is 18. That's good. What about their sum? Negative 9 plus negative 2. Negative 11. We've hit a home run. And so we can now factor this using that final entry in our chart. And we see this is going to be x minus 2 times x minus 9. Let's check and see if that really is okay or not. X times x is x squared. We have the outer terms being negative 9x, the inner terms being negative 2x. When I add them, I do get negative 11x. You can see how this chart is now filling into place. Negative 2 times negative 9 is actually positive 18. This actually checks, and you can see we're factoring now trinomial quadratics, and we're doing it quite nicely. All right, let's try some more exotic quadratic trinomials and see if we can factor them. Again, it's all practice here. If you do 1,000 of these, you're going to be the world's expert on factoring, which will be sort of fun. Maybe you can be in the Guinness World Book of Records as the fastest factorer. There's something to aspire to. Anyway, here's a quadratic, x squared plus 6x minus 16. All right, so what do we want? We want whose product is negative 16, and yet whose sum is 6. Let's just think about that for a second. We want two numbers whose product is negative 16. What can you say about those two numbers? What about their signs? Well, if the product of two numbers is going to be negative 16, they must have opposite signs. One's got to be positive, one's got to be negative. And then when I add them together, I've got to get plus 6. That actually tells me something else. It tells me what the sign of the bigger number should be. If I have a big number and a small number, and the product is going to be negative 16, one's positive, one's negative, which one's got to be the positive one? The positive one is going to be the one whose absolute value is the bigger of the two factors of 16. Because I've got to have the positive together with the negative combined to give me a positive. So actually, I'm beginning to see lots and lots and lots of structure as we try to sort of find out the right factors. I want factors now of negative 16. So one's going to be negative and one's going to be positive. Let's try negative 1 times 16. That's product is negative 16. What about their sum?
All right, hey everybody. I just wanted to come on real quick because I know you missed me. Hopefully you enjoyed Professor Berger, but I wanted to come on to just emphasize some things that was said in the video. So again, when I have a trinomial in the form of x squared plus bx plus c, I'm finding two factors of c that when you multiply them together you get c, but when you add them together you get b. Okay, x squared plus bx plus c. Okay, another wonderful form that you have to remember. Y'all smart, y'all can do it. So again, I'm looking for two factors of c that when you multiply them together you get c. That's what factors are. And when you add them together you get b. So it does not matter the order. Down here we had x plus 2 times x plus 5. I don't even remember the order they gave you, but that can be written as x plus 5 times x plus 2, because when you FOIL you will get the same thing, x squared plus 5x plus 2x plus 10 when you multiply them together. So order does not matter. That's a Christie question. Order does not matter. Okay, and so when you go to the back and you're finishing the rest on your own, we've done these with the video. Please keep in mind that I'm looking for two factors that multiply together to give me negative 16, but add together to give me 6. Okay, so look at the sign. The sign will tell you what's going on with here. So if I have a negative number, I know negative times a positive give me a negative. So I know that the larger number has to be positive when I multiply them out. When they're all the same, it's all positive. When they're the same sign, look here, I know that I have to have a negative times a positive to give me a negative, but the negative number has to be larger because this number is negative. So I just wanted to come on to just emphasize that really the sign over here is telling you whether I'm going to have two different signs or the same sign. So if this sign is negative, you automatically know I got two different signs. Adding one and subtracting one. No, it does not matter which one. Well, in these cases, it does matter which one I add and subtract. Okay, this sign tells me, hey, everything's going to be positive. This sign lets me know, that everything's going to be the same sign. Even if this was negative, two negatives equals a positive. So this is just a little shortcut. So if you look at this sign and it's negative, you know you're going to have two different signs. If you look and you see it's positive, you're going to have two of the same sign, whether they be positive or negative. And again, if it's negative, this lets you know that I'm going to have two different signs, a positive or negative. Just something to keep in mind. I just wanted to do this one real quick so that people don't feel like they're confused. So again, this is my 3y squared. So this is my, technically, 3y is my c. So when I set this up, the reason why x comes first, I gave y'all all this room, I don't know why, but x comes first because when I do my first term, this is my first term. So the only thing that gives me x squared is x times x. I don't know if that was emphasized. It wasn't emphasized that much in the video. But this is the reason why this is x. Okay, when we move on, we'll have a different term and we'll know what to do then. Alright, so x times x gives me x squared. So that's why x's go first, because this is my first term. All right, and so the sign is positive, so I know I'm adding on both times. But then this is my x squared by, or bx, plus c. So all of this is my c. So I need to break this down. And there are only two numbers that break down to give me, that multiply to give me 3y. What are the numbers? Y, or 1y, and 3y. So this is a one I threw out there so you can understand that it's the same concept. Okay, so if I do my OI, this is my outer and inner term, I can always check this by OI. Outer 3x times 3y is 3xy, plus x times y is xy. So my OI, yes, I want you to write this down because this is how you always check the middle term. Outer is 3xy plus xy. I'm going to put a 1 there for some of you all, and it's how I get my 4xy. Okay, so that's why I know that this makes that. Okay, so I just wanted to show you that. I'm going to use the word OI many times just to make sure. Check your OI, make sure they add together. So when you're moving on and you're doing the rest on your own, I just threw that one out there so you can understand that this is still in the form of x squared plus bx plus c. All right, so again, it says two factors, and when you multiply them out, you end up with this term right here. All right, so hopefully you understand that. If you don't, then hit me up on Remind. And like I always sign out, did a great job. You did a great job watching the video. This is Mr. O'Neill. You know, you're a teacher, and I'm out.